Friends, good morning. Today's subject of discussion is Traube's purine synthesis. It's purine synthesis given by Traube, and that's why it has been named after him. This is the purine ring structure. It has two rings in it. The one ring is a six-membered ring. There is a six-membered ring. It is called a six-membered ring with two nitrogens, and it is pyrimidine. Another is a five-membered ring with two nitrogen at 1 and 3 position, and it is called as imidazole. And imidazole ring and pyrimidine ring have fused together to give purine. It is imidazolopyrimidine. I can number like this: 1, 2, 3, 4, 5, 6, and 7. At 2 and 7 position, there is hydroxy group. That's why it can be named as 2, 7 dihydroxy imidazole 4, 5 D pyrimidine. I can cut this molecule over here. I'll get NCON. I will cut this molecule nitrogen. I'll cut over here methylene. First, for the synthesis of purine, as we know that it has pyrimidine ring system and imidazole ring system. Traube synthesized first the pyrimidine, and after construction of pyrimidine ring, he constructed the imidazole ring over that pyrimidine ring. The first step involves the construction of pyrimidine. For doing that, he took NCON as fragment. This fragment can be obtained from urea, NH2CONH2. I take urea as starting material, and I have 1, 2, 3 carbon donor and 1 nitrogen here. This part I have to add. CN nitrile, CH2 here, and COH I have. That's a C double bond O and an easy leaving group. Ethyl cyanoacetate. I take urea and treat with ethyl cyanoacetate. There are lone pair of electrons on the nitrogen, and the carbonyl carbon is the positive center. It attacks on this carbonyl carbon, and as ethoxy is an easy leaving group, it gets kicked off as ethoxy group, and which combines with H plus and loses ethanol, and it gives rise to corresponding uride derivative of cyanoacetate. There are lone pair of electrons on the nitrogen, and this carbon is an electron deficient center as it is adjacently having a electron withdrawing group. The lone pair of electrons attack on the carbon, and it has to maintain its tetravalency for its stability. Hence, pi electrons moves onto nitrogen, and nitrogen combines with NH plus, and it gets converted into NH. I got a cyclized ring structure, a six-membered ring with two nitrogen, partially constructed pyrimidine. Now, these electrons can move over here, forms the bond. Once these electrons are taken away, H become H plus. And once the bond is formed over here, this becomes pentavalent and it becomes unstable. To maintain its stability, pi electrons moves onto nitrogen, and once the electrons are gained from it, it becomes electron rich. And this electron rich nitrogen combines with electron deficient hydrogen. Then the carbon hydrogen bond breaks. These electrons are utilized to form the bond with the adjacent carbon, which is electron deficient center, and it has to maintain its tetravalency. That's why pi electrons moves on to the oxygen. Once the oxygen gains electrons, it becomes electron rich. This electron rich oxygen combines with electron deficient hydrogen. The bond between the nitrogen and hydrogen breaks, and the pi electrons moves onto the oxygen, and that combines with H plus. The shifting of electrons occurs, and I got pyrimidine ring structure with amino group and two OH group attached. I have constructed this pyrimidine ring system, which is being shown here with amino group at the position. Now I have to add amino group, NHN group and carbon group to this and construct the imidazole ring onto this pyrimidine. Now I have to add nitrogen onto this position. The next step is construction of the imidazole ring. I'll take the pyrimidine ring which is constructed and treat with sodium nitrate and HCl at 0 to 5 degrees centigrade. Sodium ion Na plus reacts with Cl minus to give rise to NaCl, H plus and NO2 minus combine together to give HNO2, a nitrous acid, which is unstable and it is in situ prepared. The nitrogen is the positive center as it has an electron withdrawing oxygen group. It acts as an electrophile. In the presence of an electrophile, electromeric effect occurs and the pi electrons moves towards one carbon creating an electron rich center, and here once the electrons are moved, this becomes positive. This electron rich carbon, the carbon ion which is formed, attacks on this electron deficient nitrogen and kicks off OH. I'll get corresponding nitroso derivative of pyrimidine. This nitroso derivative of pyrimidine I will treat with ammonium sulfide, a reducing agent, and nitroso group gets reduced to amino. I got diamino derivative of pyrimidine. There is lone pair of electrons and I have to add a carbon and it should be bonded with both this nitrogen and I get a imidazole ring system. To add carbon, I'll treat with formic acid. This is electron rich center and carbonyl carbon is electron deficient center. Electrons attack on the carbonyl carbon and OH gets kicked off. What will I get? The NHC double bond OH. The nitrogen in this has lone pair of electrons and this lone pair of electrons attack on the carbonyl carbon and there is no easy leaving group. That's why pi electrons moves onto the oxygen and gets converted into OH. And imidazole ring got constructed over the pyrimidine ring. Now it undergo dehydration. The nitrogen and hydrogen breaks bond and the burst electrons are bonded with this adjacent carbon and it has to maintain its tetravalency. That's why OH lose out along with its electron pair OH minus and this H plus, they combine together to lose as water molecule and I have got purine molecule synthesized. This is the method given by Traube and it has been named after him. There are other methods of synthesis of purine where imidazole ring has been constructed first and then pyrimidine is built over the imidazole ring. But this is more versatile route which was given by Traube and that's why it has been named after him. Next class we can deal with another heterocyclic molecule synthesis. Till then, have a nice day. Thank you.